Hello, hello. Are you all able to hear? So everybody is able to hear properly. We'll start then. So let's start the session, okay? Okay. So we are doing the chapter matrices. Everybody is there? Just check. Vimal, others, do join fast. Come on, come on. Just ping it when you join it. Okay, put it in the chat. Once you have joined, come on fast. We have to finish this. Come on, put it in the chat section. Whoever is joining, put your name. Vimal has joined. What about others? Do join fast, students. Hi Heath. Okay, Heath also joined. Karthik joined. Okay, so we'll be finishing highlights corner. Hi, we'll be finishing matrices for the Kcet and Comedk, the concept part. So whatever is required, everything will get it done. PYQs then will start. Okay, so till now we have just gone through the basics of the matrices. Okay, the pretty much basics part. Okay. So in that, just recapping it in very fast moment, okay? Whatever we have done, Akhilesh joined, okay? Till the time I'll just give 3 more minutes max to join, otherwise we're done. So this is the way we denote a matrices, okay? We talked about what's a matrix is, just a rectangular arrangement of data. Data can be anything. You put numbers, you put hierarchy, or you put real numbers, functions, anything you can put. Okay. Next we'll talk about how do we denote it. Very simple method. Whenever we write a matrix, we can use this bracket or this bracket. A matrix A is written as A of ij, where I denotes the number of row, which row it is, and j denotes the number of columns. Okay. So when I write the first element A11, it means what? This element belongs to the first row and first column. A11 means first row, first column. So same way we can write. Now for a matrix having m rows, okay, 1, 2, 3 up to m, and n columns, 1, 2, 3, 4 up to n. So it is denoted by A m cross n. That's the order of the matrix. Whoever is joining, do ping it name. Okay, just ping it fast. Clear? Now I asked you one simple question also keeps coming up. A matrix has 16 elements, so what is the possible order? Just multiply, find the factors, you will get it. 16 how, which ways we can write? What are the factors of 16? 1, 16, 2, 8. So 8, 2 also, and 4 and 4. That's it. Okay. Construction we all know. Okay, there is no doubt anything about it. How do we construct? Put the values and get the answer. Construction, nothing is there. Just put the value and get the answer. Nothing is there in this part. Row matrix we already know. A matrix which has one row. Column matrix, a matrix which has just one column. Nothing more than that. What is zero, null or void matrix? We just talked about zero, null or void. All three. Okay. To that matrix we say if each and every element is zero. Understand, each and every element has to be zero. Square matrix, row and column same. Square matrix very important, row and column same. Okay. Now, then we talked about the trace, very important. Okay, keep it in mind. A lot of time they'll give you a question, what is the trace of a diagonal matrix? So what we can do, just add the leading diagonals. Add the leading diagonals. Okay, like here A11, A22, A33. If somebody asks find the trace of this matrix A, then what do you want to do? A11 plus A22 plus A33. Done. Clear? No issues, Lebo, okay? But yeah, be on time. Scalar matrix. First, a matrix has to be square, then it has to be a diagonal, and then if in the diagonal ones, if all the elements, diagonal elements are same, then it becomes scalar. Now, once it becomes scalar, if each and every element becomes equal to 1, we call it as identity. That's it, nothing more than that. Singleton means one element, single means one, so singleton means 1. Now what is triangular? Triangle means it is forming the elements together, they are forming some triangle shape. They can form either a upper triangle or a lower triangle, whichever it is. Okay. This is the recap, very basic, very simple. So just taking it bit fast. Anywhere doubt, put it in the comment section, okay? Because these all things you all know. So where it is like very important, I'll go a bit slow. Otherwise, I'll go fast. Very important, equality of matrix. Two matrices are said to be equal if they follow two conditions. Two matrices are said to be equal if they follow two conditions. What is the condition? Number one, same order. Number one, same order. Number two, each element of the first will be equal to the corresponding element of the second. Okay, the first element of the first will be equal to the first element of the second. Second element of the first will be equal to the second element of the second, like that. Okay, so very important. They're going to give you a question like this. Here you have to be fast. It's very simple. You have to be fast and get the answer. Be fast and get the answer. Okay. Chalo, very good important question. Again, let me just twist this question and let's see, a lot of people, they have tried also, they have done also. Let's see how many will be able to do. If I change it, let's change the question and give it to all the people. The total number of matrices of order 2 cross 2, where we can either put the values of cube roots of unity. Let's see. A bit, I'm giving everybody to think. Let's see, you can think. Come on fast. Let's see how many people can think. I'm giving you a timeline, 1 minute. Let's see. One second, students. Are you having issues with the audio? One second. Do you all having issues with the audio? Hello? 3 to the power 4. Anybody having difficulty with the audio, please tell me. But I think so sound is going high. Heath 1. Sound is not clear, Karthik. Okay. Just give me 1 second. Okay. दरवाजा लगा दीजिए. 1 second guys, just 1 second. 81, a lot of people have written 81. Okay, 3 power 4, 81. What about others? Come on, think. Where is other kids? Akash not there. So a lot of people, they have sent the answer, and there is a 1 minute delay here also. Okay, we are having 1 minute delay. Everywhere is problem. What? Come on, give a break. There's a one. Is the audio now coming okay? No, it's again going bad. Is it okay now? Come on. Put in the chat fast. Is the audio coming good, bad, good, bad? There's a delay in your replies also. Is the audio okay? Hello. Let's see. Hello. It is fine but not very good. Akhilesh, yes, okay. How much delay is there in the... Okay, let's see. So a lot of people first will draw. It's a 2x2 matrix, correct? Is the sound now okay? Everybody check it once. Is the sound now okay, good, bad, how it is? Comment fast. Lag is 30 seconds. Sound is okay, I think so. Okay. A lot of people, they're asking what is a Kcet exam might postpone again. We don't know. Okay. So Kcet exam might postpone. We maybe not. We don't know. Okay. So don't sit on that. Okay. Keep studying. If it postpones, well and good. Doesn't also, well and good. Whatever we have, we can't. Okay. Sound is very low. Chances are very low. Sound is coming low. Okay. 1 second. We reduced the noise part, but it became very low. 1 second. It was good before, no? Yeah. Voice became low. Okay. Today something or the other. Okay. No, keep it high only. High is okay. Now is it okay? Now is it okay? Hello? Is now the sound okay? Tell me fast. Is it okay? Is it coming? Come on, come on, come on, fast. Is it still low? Perfect. Okay, okay. We are good to go. Let's start it then. So what we had here is, so we have a 2 cross 2, very simple thing, okay. Think like this, 2 cross 2 matrix, how many elements? 4 elements, means 4 dabbas are there. 1 dabba here, 1 dabba here, 1 dabba here, 1 dabba here, okay. What we can put here? Cube roots of unity. How many? 1 omega omega square. These are the 3. So 3 values we can put. 3 options I have here. Akash, it's a bit louder. Okay. Okay. I'm from which place? Right now, currently Bangalore. Okay. Now what I'm telling is 3 dabbas we have here. So what are the options you have? Either you can put 1 omega or omega square. So per dabba, how many choice? 3. How many times? 3, 3, 3 and 3. So 3 power 4. Very simple. That's it. So we don't have to think a lot too in depth or too difficult. Nothing is there. Okay. The whole question was like very simple. Just they wanted you to have a fear. Oh, cube roots of unity. You just need to know what are cube roots of unity. 1 omega omega square. That's it. Okay. Clear? Now coming to the next operations. What are the operations we perform on matrices? Okay. The first, very simple, addition. When can we add? We can add two things when they have same order. If the order is different, we can't add. No. Then, so very simple. Add it. Done. Chill. Next, multiplication. Very important multiplication part. Whenever we multiply a constant with a matrix, what happens? Each and every element is multiplied by that. Each and every element is multiplied by that. Clear? So very, very important this part. A lot of questions will be given matrix multiplication with a constant and determinant multiplication with a constant. Their student will do silly mistake and gone case. Clear? So never do that kind of mistake. Difference is same thing. Multiply with a minus sign, then add it. Clear? What is difference? Multiply with a negative sign, add it. That's it. Clear? Matrix multiplication separately we'll do in detail also. Don't worry. Okay. Now coming to the addition properties. Commutative, we all know what is commutative. If 2 plus 3 is 3 plus 2, same thing, commutative. Whether you add first and second or second and first, same thing. Associative, whether 2 people are added first and then added with the third, means I am taking 3 matrices, I am adding these 2, then adding with the third, or I am adding the last 2 and then adding with the first. Same thing, no issues. Clear? Screen is not proper. What you are not able to see in the screen, heat? Or screen, okay, delay is there in the screen part, correct? iPad screen is lagging, correct? What I am teaching right now and what is it showing in that? Okay, AS server went. One second. It came now, no? Screen is hanged, yeah. When problem comes, it knocks on all the doors, okay? Not leaving one single door. But still, whatever happens, we'll keep the class, okay? Now it is okay. We'll keep doing, we'll keep moving, okay? Whatever problem comes. Is it now okay, students? Are you all able to see a first one I'm adding? Are you all able to see? So I'll go a bit slow here. Okay, done. Okay. So associative, we all know, very simple. What about inverse? We all know. Take a matrix, take a negative of that, add it, will get 0. No issues in that. Correct? Now what about identity? Add a matrix with 0, add a matrix with 0. Okay, or a null matrix. So what you'll get? The same matrix, nothing more. Clear? So these are very simple property. What about scalar multiplication? Again, this is important. Right now it doesn't seem, but when in exam they'll trick it and give it, you'll be having difficulty. So very simple, always keep in mind, matrix multiplication means each and every element is multiplied. Determinant, it is different, okay? That's why I'm giving you a lot of priority in this part. Now these properties again same thing. If I have a constant multiplied with two matrix, I can do separately also. First multiply and then add. Again I can do first multiply with m then multiply with n. Very simple. If I have two constant, I can do Ka and then multiply with the other constant, or the other constant first and then with the first constant. No issues in that. Very simple. So this page, anybody has any doubt? Put it in the chat section fast, fast, fast. Don't delay. If you have doubt, put D. If you don't have doubt, put ND. If you have a doubt, put D. If you don't have a doubt, put ND. Fast. We'll go for the next page. Come on, students. I haven't kept a water bottle. Oh. Doubt, no doubt. Chat section, a bit fast reply. Okay, no doubt. Now, let's see the next page. Multiplication. We all are aware with the multiplication part. Correct. Very simple, very easy. What we do, the condition of multiplication, very important. A lot of questions will be from the condition part. Okay. Even for your JEEs also, a lot of question comes from the condition part. Condition part, one's very, very important. Third property, Akash. This one. See, you have two constant, 2 and one is 3 and then a matrix. So you can do first 2 times of that matrix and then multiply with 3, or 3 times of that matrix and then multiply with 2. So same thing, Akash, nothing more than that. Clear, huh? Now, coming to the property here. Okay, matrix multiplication, okay, very, very, very important, matrix multiplication. So what we have in matrix multiplication, a bit delay I'm able to see. Okay. Delay is a bit good, like 30 seconds lag is there. Okay, now matrix multiplication. In matrix multiplication, very, very, very important. What is the rule? The column of first should be equal to the row of second. Column of first should be equal to the row of second. These two has to be equal. Then only we can multiply. Okay. Column of the first should be equal to the row of the second. Say it out loud. When you're studying with me, do say it also. So what happens then and there, here only we'll do the revision. Okay. Because nobody will be there, lock the room, just start and say it loud. No issues. Okay. So column of the first is equal to row of the second. Clear? And the resultant will be what? This part left and this part left. That is the resultant. Clear? So let's say I'm giving you a very simple question. A is 3 cross X and B is 5 cross Y. Find the value of X and Y if they are AB is multiplicable. AB is multiplicable. Fast, fast, fast. Come on, everybody. Let's see who's giving the first answer. Come on, students. Let's see. A very simple question. A is given, B is given. They are telling you to find the value of X and Y, and they have said that AB is multiplicable. AB is multiplicable means the product of AB exists. AB can be multiplied. So come on, let's see who can give the answer. X is 5, one answer we are getting X5, what about others? One buddy is saying a Karthik X equal to 5, what about others? Why so much time? Come on, you have to be like, what do you say, fingertips, seconds, come on, fast. X is 5, okay, Vinayak, X is 5, what about the Y? Why are you so scared about Y? Is Y dangerous? So, very good, X is 5, we can't say anything about Y. We can't say anything about Y. Because we know the resultant, what will AB will be formed, that will be AB will be what? The resultant AB will be what? Y is 3. Now they are multiplicable. So column of second, multiplicable means, understand, multiplicable means what? Only one rule. Multiplicable means only one rule. What is that rule? Column of second equal to row first. Column of second equal to row first. Nothing else. Column of second equal to row first. Extra don't add from here. We don't need masala or something, okay? Plain rice. Clear? Column of first equal to row of second. That's it. X equal to 5. Nothing extra we can say. Until unless they have given us something extra data. Clear? Nothing extra we can say until unless they have given us something other data. If AB can be multiplied, only X equal to 5. Nothing we can predict about Y. What will be the resultant? What will be the resultant? AB will be 3 cross Y. That we can say. But what will be the value of Y? We can't say. Clear everyone? Clear heat? Everybody, is it clear? Yes, no? Put it in the chat section. Everybody, is it clear? Yes, no? Voice and video lag is good. We have to figure out. Lag is okay. Lag is good. Good. Okay. Clear, clear, clear. Okay. Now, coming to the next part. Just a simple multiplication, no need to do. I know you all are good in multiplication part. Okay. But how do we multiply? I'll just show you one. I'll just take an example, show you one. You all know multiplication, correct? So A is equal to, I have given 1, 2, 3, 4. And B is equal to, multiply and give me, let's see, 2, 3, 1, 6. What will be the answer? Let's see. Multiply AB. How do you multiply? There is no lag. Okay, then good, good. I've given a question. A is equal to a matrix 2 cross 2, 1, 2, 3, 4. B is another matrix which is 2, 3, 1, 6. Everybody sit with a pen and a paper. Okay. So today's class is about maths, so sit with pen and a paper. The day will sit for a gaming class or something else. Will not sit with pen and paper. Okay. So today sit with pen and paper. So what if we multiply, what will we be getting? Very simple, just wanted to show how do we multiply. A lot of methods are there. What you can say? First, see, if I say this first element is what? A11. Row of this, column of this. So one row we have taken, one column we have taken. Multiply them. One row, one column we have taken, one row from the first, one row from the first, and one column from the second. So when we multiply, what you will get? 1 into 2 plus 2 into 1. So we'll get 4 here. And then this is the second element is what? A12. Row of first, second column. This one and then other column. So 1 into 3 plus 6 into 2. So what we'll get? 3 plus 12, 15. Then here, this element is what? A21. Second row, first column. This one and this one. So 3 into 2, 6. Plus 4 into 1, so 10. And then A22, this one and this one, 3 into 3, 9 plus 4 into 6, so 9 plus 24, and that is equal to 33. Very good, Lucky, very good, Karthik. Okay. What about others? Heat and Vinayak, Akash, Vimal. Come on, I need answers from all of you, okay? Clear, huh? What are the answers? 4, 15, 10 and 33. Very simple. Now coming to the next. Properties. What are the properties? Once it is done, coming to the next, the properties. So a lot of properties are there. Basics ones we all know. What are these? Commutative, Yes or no? See, can we say if AB is multiplicable, then guaranteed BA is also multiplicable? Illa, we can't say that. Can we say that? If AB is multiplicable, can we say that BA is also multiplicable? No. We cannot with a guarantee say it. Okay? With a guarantee we can't say it. Clear? So let's say A is, let's take an example, understand A is 2 cross 3 and B is let's say 3 cross 5. So if I see AB, is AB multiplicable in this case? Tell me everybody. I have taken A, which is 2 cross 3 or 2 cross 3, and I have taken B, which is 3 cross 5. Is AB multiplicable? Put it in the chat section everybody, put it in the chat section everybody fast. Come on, fast. We can say AB is multiplicable. Karthik, first answer we got, multiplicable, lucky also. BA not possible. Very good. What if we try for BA? What if we try for BA? So BA, what will happen? B is this, A is this, 3 cross 5, 2 cross 3. These two not same, so not possible. These two not same, not possible. Very good students. Next, associative. If they are one side associative, the other side will happen. If A and B, they are multiplicable and the product is multiplicable to C. If you see the other way around, it also will be happening. You can check with an example, you can see it will happen. Okay. Distributive, again it will happen. In distributive also it will happen. Okay. You can just take a random example and see. Very easy. Now this point is very important. If they say that the matrix AB is equal to 0, what does it means? A lot of question came on this. If AB is equal to 0, it does not necessarily mean that either A or B has to be 0. It does not guarantee that A or B has to be 0 for getting the product AB 0. Clear? A can be any matrix, B can be any matrix, non-zero ones. And if I multiply both of them, I'm getting all elements 0, 0, 0, 0, 0, 0. It can be like that. Okay? So we cannot say when they say AB equal to 0, directly we can't say, sir, AB equal to 0 means one of them has to be 0. No, it's not like normal integers. Clear? Everybody? Yes, no, put it in the chat section in between, keep recharging the battery and do put up yes, no, okay. Now the last part, this part not that important, okay, but this part is important. Everybody see this part, the last one. If they have given AB is equal to AC, then what we can do, and the matrix A is not equal to 0, we can cancel this part. We can cancel this part and we can say B is equal to C. So one is left cancellation, one is right cancellation. Clear? Now if DA is equal to CA and A is not equal to 0, so we can do right cancellation and we can say that D is equal to C. Clear everybody? Clear everyone? The cancellation part? Yes. Good. So I'm going to the next big section, the transpose, the property, symmetric, skew-symmetric, inverse using elementary row operation. Clear? Huh? We'll move to that part. Nobody has any doubts? Next we start with transpose. Transpose means make it ulta. Transpose means change it. Top to bottom, bottom to top. Just make the change whole. Let's take a very simple example for transpose. Okay. I have taken A is equal to 1, 2, 3, 4. So very simple, whatever is row, convert it into column. Whatever is column, convert it into row. That's it. So what we have in the first row 1 and 2, make it into column 1 and 2. Now whatever we have in the row 2, that is 3 and 4, make it into column 2, 3 and 4, done. So this is the transpose. Clear? Row converted to column, column converted to row. That's it. Clear everyone? Row is getting converted to column and column getting converted to row. That's it. Clear everyone? Clear? Now, so what is it? Matrix obtained by interchanging rows and column. Very simple. We denote it by dash also and T sign, transpose sign. Dash also, T sign also, okay? Both. If we have 3 cross 2, it will become 2 cross 3. Row will get converted into column, column will get converted into row. That's it. Coming to properties. Few of the properties are very good and that we'll be using it. So let's see which are those good properties. Okay. See, if you have transpose once and if you retranspose, what will happen? We'll get back the same thing. But in reality, in life, does it happens? You go somewhere, slap a person in one time, and then again to make it same, re-slap it. So what will happen? You'll get a good beating. He won't leave you, correct? But here, if you have done a transpose and if you have done once more, you'll come back to the same thing. Clear? Now, here what is important is this part. The fourth property is very important. Fourth property is very important. If I do AB whole transpose, then what will happen? It will open it as second transpose, the second matrix what we have, second matrix transpose into first matrix transpose. Very important. Okay? Clear? If I do AB whole transpose, that will be written as B transpose dot A transpose. Very simple but important. Now, if I have power, a lot of times what happens, normally when we see power, it's okay. But what if somebody has written A power 7 and then transpose? It's same thing as you transpose it and then put the power 7. So don't get scared. Clear? In exam, don't get scared. Anything power, whatever it is, doesn't matter. Same thing. Okay? Now, if they give you more than 3 or 4 elements, sometimes they have given for CET and Comedk, they have given A, B, C whole transpose. So what are you going to do? The last one will come first. The last one will come first. So first we'll have C transpose, then the next last, and then the first one. Clear everybody? Clear this part? Okay. So as a exam part, you can verify it. Now inverse also we'll do it later. Don't worry, once we'll go for the inverse of a matrix. AB whole inverse behaves the same thing. Okay. Done. So everybody till here, all clear. Any doubt in this page? Anybody, any doubt in this page? If no doubt, just put an ND in the chat section fast. Clear? Okay, next. Any doubt, anybody? Yes, no, please do, students, do say, okay. Now, very important. For those who are still sleeping, do wake up. Okay, exam is near. Clear? So, symmetric and skew-symmetric. What is symmetric? if we did the transpose and we get the same thing, so then what? Symmetric. Very simple. If you have done the transpose, A transpose we did, and luckily what happened, A transpose became A. So then directly you can say, whoa, that's pretty chill, that is symmetric. And if we have done A transpose, but instead of getting A, we got minus of A, then we can say life is pretty harsh, and that is skew-symmetric. Clear? This is symmetric and skew-symmetric. Now, one very, very good question that we'll ask you all in the next class. Do tell me the answer of this one. Can all square matrix be divided into two types, that is symmetric and skew-symmetric? If yes, then why? If no, then why? A question to think. Okay? Can all square matrix be divided into two parts, square, symmetric and non-symmetric, or skew-symmetric? If yes, then why? If no, then why? Okay? Clear? Now, a very important question here also keeps coming up. If they say that the diagonal elements of a skew-symmetric is 0, why? For skew-symmetric, diagonal elements are 0. Do you know the reason why? See, very simple. If I take matrix A, let's say matrix A, very simple, we'll take A11, A12, A21, A22. If I do the transpose, student, if I do the transpose, what I'll get? Okay, I should get in such a way that it should be negative of minus A, correct? So, if you see the diagonal elements, if I add these two, see, A transpose equal to minus A. If I bring it and add A transpose plus A, it has to be 0. So when can A transpose and A, if it is 0, it means what? All the diagonal elements, this and this will be 0. Why? Because A of I will be equal to minus of A of I, because for I equal to J. So if you bring it both one side, twice of A of I will be equal to what? 0. So A of I will be what? I will be what? Equal to 0 only. Clear? This part, is it clear or it went above the head? Clear or went above the head? Put it in the chat section. Yes, no, yes, no. Or I'll again explain, no issues in that. What about others? Karthik, Akash not writing. Is it yes, you got it, you didn't get? Come on, come on, come on. Others also I want to see, no doubt. If doubt is there, do tell, I'll explain it. No issues in having any kind of shame or something. We're here to learn, all of us. Come on, come on. Okay. So nobody is saying anything. Okay, next. Then we'll go for the next page. Very important. Now, so if A transpose equal to A, symmetric, very simple. Okay. For skew symmetric, always the diagonal elements will be 0. Always the leading diagonal elements will be 0. Clear? For a skew symmetric, always the leading diagonal elements will be 0. Clear? Okay. Now I've just given an example. This property, this page and this page, very important. Directly a lot of questions from exemplar also, we have made it into property and kept it here. So directly you can, see the question in the CET exam, Comedk exam and tick the answer. 5 seconds, that's it. Clear? So what is the question? First, you take a symmetric and you take a matrix and take a transpose, add it up. Always you will get symmetric. What I am telling, take a matrix, add with its transpose. What you will get? Always symmetric. Take a matrix, subtract with its transpose. Always you will get skew symmetric. Clear? Take a matrix, add with transpose, you will get symmetric. Take a matrix, subtract with transpose, you will get skew symmetric. Clear? Any doubt? Any doubt? Okay. We all know this. For any square matrix, we can write in the form of symmetric part and in the form of skew symmetric part. Very simple. Okay. Now, this property, very important. If A and B are symmetric and AB is given equal to BA, then what you can say? AB is symmetric. A and B both symmetric, and they have given that AB, if you multiply A and B, or if you multiply B and A, both are same, it means that AB has to be symmetric only. Then only it can happen. Clear? Very important. You can keep that in mind. If A and B are symmetric and AB is equal to BA, it can only happen if whole of AB is symmetric. Clear? Clear everyone? Doubt? Any? Do? Tell? If not, we'll move on ahead. Come on fast. Any doubt? Do tell it fast. Excuse me. Okay. Next. Now very important this part for your CT and Comedk. If they have given three matrix like this, one is the transpose, one matrix, and then the normal matrix. Matrix, it's transpose, and then in between A. So in this case, it will be symmetric or skew symmetric, will depend on the middle matrix. Last property you want me to repeat, correct, Karthik? Let's come to the last property. Very simple, very easy. Okay, what they have given is, if I have a matrix A, if I add it is symmetric, means let's just show it only. A transpose is equal to A kid, B transpose is equal to B, correct? This one we know. A transpose A, B transpose B. Now, and they gave AB is equal to BA. This also they gave it. Now they're telling me to show whether AB is symmetric or not. So what I'm going to do? I'll check. I'll do AB whole transpose. If I do AB whole transpose, what I'm going to get? B transpose, second will come first, into A transpose. So B transpose is what? B, and A transpose is what? A. But right now I already know that AB is equal to BA. So instead of B I can write AB. So done. So what I'm getting? AB whole transpose is equal to AB only. So can I say that AB is symmetric? Yes or no, kids? Very simple. Got it, Karthik? Karthikeya, did you get it? Yes, no? And don't hesitate to ask doubts, kids, okay? Doubts asking is very important. Clear? Yes, no, yes, no? Clear. Now again, see, once more, sometimes in the pressure also we say yes. Okay, so again you go home, understand, do it. If again doubt, next session again ask it. Okay, don't go with a confused mind to the exam. If you go like that, you'll have a chance of doing error. So never go like that way. Clear? Let's see the next part. So this part will just erase it, omit it. Now next, what you have in the next part is very important property. And what is that is, let's see. Now they have given us a condition like this. One matrix transpose, another matrix, and then normal of that. So the whole thing depends on this middle person. Okay, if the middle person is symmetric, whole answer will be symmetric. Middle person skew symmetric, whole answer will be skew symmetric. Very simple. Nothing to put brain into that. Clear? Clear everyone? Okay. Now this second one again very important. If A is a symmetric one, then A power n is symmetric if it is positive integral. Means if A is symmetric, you put A square, A cube, A power 4. Directly you can say symmetric only. Clear? directly you can say symmetric. The moment they said A is equal to symmetric, and they said find the will A power 3 will be symmetric. Don't start going calculation, okay? A square is what, sir? And then you're checking it is symmetric or not. Illa, we don't have time. Okay, 1 second, 2 second, directly you can say symmetric. If it is a positive integral, directly symmetric. Nothing here and there. Clear, everyone? Lucky, Karthik, Akash, clear? Yes, no? Come on, come on, come on. Yes, no, yes, no. Come on, put it in the chat. At least we'll get to know. I know a bit delay is there, a bit lag, but still, we have to work hard. Target is big. So working, hard work is the only thing, okay, that we have. Now next, any doubt, any doubt? Okay, clear. Now, sir, you said for symmetric. Very good, well done, sir. What about skew-symmetric, sir? So if we have A is a skew-symmetric part, then it depends. It depends on what, sir? If it is even integer, like A square, then directly put symmetric. If it is an odd integer, A cube, skew-symmetric. Clear? Just like negative number, minus 1 power any even power, minus 1 power any even. So it will be what? Positive number. And power any odd, it will be what? Negative number. Same thing. So whenever we have a skew-symmetric, power even, so directly you can write symmetric, and power odd, so you can write skew-symmetric. Everybody got it? Everybody got it? Yes, no in the chat section. Come on, very important. Okay, next. If A transpose is equal to minus A, means skew-symmetric. Same thing we have written, okay? Now, if a matrix is both symmetric and skew-symmetric, directly, a matrix which is both symmetric and skew-symmetric, it has to be a null matrix. Nothing else other than that can exist. A matrix, the moment they say it is symmetric and skew, both, okay, it means it is a null matrix. Means a person having positive charge and the negative charge equal amount, it means what? The person is neutral. Correct. So person having positive charge, negative charge, so it's a neutral person. That's it. Clear? Everybody got clear this page? Any doubt? Anything? Come on, fast, fast, fast. Yes, no, kids, put it in the chat section. Yes and no, yes and no. We'll move on to the next page. Any doubts? Any doubts? Anybody? Okay. We'll go for the next page. Any doubt? Anybody? Okay, lucky sir, no doubt. Now, A and B, A is symmetric, B is symmetric. Then A and B of same order. Very important. See, a lot of questions we do. Then if you do AB minus BA, skew symmetric. AB plus BA, symmetric. A plus B, symmetric. Whenever you are adding it up, it's symmetric part. You can do and solve it and see it also. No issues. Or you can keep in mind also. Okay. So A and B are symmetric and they both are of same order. So if I do AB, it will be symmetric part, and if I subtract them, then what will happen? It will be skew. Otherwise, if you add it or just normal two symmetric, you add it, you will always get symmetric only. But subtraction creates skew symmetric. Subtraction creates skew symmetric part. Clear? Come on. This part was very important. 2 times questions came in CET and 1 time in Comedk. Directly this part. A and B symmetric they have given. Now they have told what about this. Once they have given this, they have asked what about this. Clear? When we'll be doing the PYQs, you'll be able to see, sir, these are all from the concepts part. Very simple, very easy. Okay, 3 seconds, 5 seconds, that's it. Clear? Any doubt in the chat section? We'll go for the next page. And the next page is inverse of a matrix. Inverse of a matrix. Come on, any doubt? How many of you are hungry? Too much hungry? Yes, no, come on in the chat section. Too much hungry? Nobody? That's pretty impressive. Nobody's hungry? Yes, no. What about being hungry? Lucky sir. Hungry, not hungry? Nobody's saying. Wow. Is it lagging too much? Or you're feeling shy to say? Come on. Hungry for marks, for food, both. Both. Yes, we have to be definitely hungry for marks. Okay. So nobody's like hungry for food, no, as of now. Okay, good. So let's see next. Next page, inverse, very important. Inverse is what? When we have two matrices, if you multiply them, you get an identity. It means the first is inverse of other. Very simple. Okay. So let's say I have a 2, I have 1 by 2. So can we say 1 by 2 is inverse of 2? Because in this case, if I multiply them, I'll get 1. Clear? So same thing in kind of matrix part. If I have matrix A, if I multiply with matrix B, and if I'm able to generate an identity matrix, then done case. Clear? Now how do we find the inverse and everything? We'll teach. We'll come to that. As of now, this is inverse. And inverse of a square, what is a square matrix? If it exists, means if inverse exists, we'll see the condition when it exists. Okay. Always unique. Can you tell me the inverse of 2 other than half? Anybody? What is inverse of 2 other than half? Can you tell me the inverse of 2 other than half? Anybody? Come on. Inverse of 2 other than half. Nothing? Correct. So inverse is always unique. Okay. Now how do we perform elementary row operation? So we don't need, in exam we don't need elementary row operation. We'll use a trick. Okay. To solve the questions of elementary row, operation, we'll use a trick in that. Okay. Still I have given you can interchange, you can multiply with any scalar, you can multiply and then add with any other row. These 3 operations we can perform, except that no other. But yeah, we won't be doing these all things in the exam. We'll have a very simple short trick to solve it. Clear? Huh? Next. Now, a lot of times what they'll do, a bit extra. Sometimes Kcet and Comedk, they go haywire like this. So in that case, you should know what is an orthogonal matrix. What's an orthogonal? If I take A, multiply with transpose and I generate an identity. Say it with me. If I take a matrix A, multiply with transpose and generate the identity. Clear? What I said? I took a matrix A, multiply with transpose, I generated an identity. So it means what? A is orthogonal. Clear everyone? Yes, no, very important. Next, I have taken a matrix A and any power, like let's say A cube is equal to 0, then we can say that matrix is what? Nilpotent at P equal to whatever the value it is getting. Clear? What about idempotent? If A square is equal to A, we can say idempotent. If A square equal to A, we can say idempotent. Very simple, just you have to keep it in mind, nothing else. Involutory, A square equal to identity matrix. A square equal to identity matrix. So these four special types very important. Keep it in mind. Everybody, these four special types keeps coming here or there. Yeah, that is always identity. Correct. But A transpose, rare case. In that case, when it happens, we say orthogonal. Clear, Karthike? See, 2.5, always 1. But some other number came and it is able to make it 1, then that is, in case of matrix, orthogonality. Clear, huh? Everybody clear? Everybody clear? Karthike, everybody clear, huh? So matrix part almost done. We'll start with our best buddy, the determinant bros. Determinant, and along with that, what else? Adjoint and inverse in more details, okay? Let's finish it up. So just give me 1-2 minutes of break. Okay, just bring the water bottle and get it done, okay? So be there, don't go anywhere, okay? Hello, 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 hello. Is voice coming properly? Hello, hello. Are you all able to hear? Yes, no, students. Are you all able to hear? Yes, no, fast. Are you all able to hear? Yes, no. Is it loud? Okay. Is the voice loud or is it okay? Is it loud or is it okay? Audible. You want me to increase the voice or you want me to decrease it? You want me to increase the voice or you want me to keep it like this? You want me to keep it like this? Allowed it. Okay, okay. Is now okay? पहले it was fine. चलो थोड़ा पहले कर देते. अभी ठीक है? Is it good to go now? No, it's coming in the red zone. 1 second. Okay. Now is it? How is it? Hello. How is the voice now? Okay, not okay? Earlier it was good. Okay. Then we'll start now. Okay, okay. Perfect, perfect. Okay. Somebody has asked about the physics part. Yes, physics will be doing. Today got a bit late, so tomorrow we'll be doing more of physics because maths will be finishing a bit more. Today this part. Okay. Now is it proper? Let's start then. Okay. Let's start it now. Okay. Perfect. Now matrices, I don't think so now anybody will have any difficulty. Now coming to the determinant part. In determinant, what we have here is, first, what is the determinant? The value associated with a square matrix. Every square matrix, no other, okay? Every square matrix has a unique value and that unique value is known as the determinant. Clear? Every square matrix has a unique value and that unique value is the determinant part. That's it. Clear? Okay. Now, how do we understand all that and what is the use in that? Okay, we'll try to understand with this equation. You remembered in class 9th and 10th we used to do linear equation in two variables and then we used to find these two represents two lines. So if they're intersecting, one solution. If they're parallel, no solution. If they're overlapping, infinite solutions. Correct? Yes or no? Do remember the old golden days of 9th and 10th? The life was so chill that time. Correct? Now, so we'll be teaching and talking about what is this determinant and what is this value. So basically, if you see a line equation like this, okay, this is a line equation, let's say, then the value a1 b2 minus a2 b1, okay, this value is nothing but the determinant. This value is nothing but the determinant, correct? So for any matrix, square matrix like 1, 3, 4, 5, what is the determinant value? What we do? Top to bottom we multiply. So 1 into 5 minus bottom to top. So 4 into 3. So 5 minus 12, how much, students? Minus 7. That's it. Clear? Very simple. Any doubt? Any difficulty? Any doubt? Any difficulty? Any one kid? Nope. If all good, it's okay. We'll go for the next part. Very simple. So this was determinant part. I think so everybody knows that. Okay. Let's go to the next part. So for every square matrix, okay, a number, it can be real, it can be complex. Here sometimes they'll make you, oh, matrix value determinant. Okay. It's always the value of a square matrix is always comes real. Now a lot of people, sir, tick correct. Will be done case. It can be a complex also. It can be a complex also. Let's say I'm taking a square matrix and I'm putting complex value 1 omega, omega and omega square. Will I get a real value? No. I'll get a complex value. So always understand, clear. Concepts are very, 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 very important rather than mugging it up. Okay. Just mugging it up won't help. Okay. Clear? Now, okay. Next. So a number, it can be real, it can be complex. Very important. Number can be real, can be complex, which is associated with a square matrix, and that is the determinant. So determinant of a square matrix is nothing but, we write in this, what do you say, two Dundas form like a modulus, and that is given by, but it is not actually modulus, okay, AD minus BC. Though this is nothing but the determinant of, denoted by det A, determinant of square matrix A, determinant of square matrix A. Clear everyone? Clear everyone? Okay, next. Next what we have is a determinant of matrix of order 1. If it is just one order, value same. Clear? Just one order only, what we can do? Value same. Okay? Next, order 2 if it is. What we'll do? We'll solve it. Order, still, is there a lag in the screen, students? Because I can see there is a lag. Is there a lag from your side also, like you're seeing the lag? Okay, no lag, okay. Then okay. Okay. Now, order 2, very simple. We know how to find the determinant. We'll do it easily. Okay. Top to bottom minus bottom to top. So A11, A22 minus A21, A12. That's it. Clear? Now, let me give you a simple question. Okay. Before proceeding further, let's say the question is, the determinant of this x plus 1, x minus 1 and x is equal to 7. Solve it. Let's see who can solve it. No lag is there. I do have offline classes, what do you say, in Bangalore, BTM's place. Okay, but since a lot of people are from a lot of different places, so we do have online also. 1. Karthike, answer 1. What about others? Seven. Oh, is it 1 or 7? What are you asking? What is your answer? 1 or 7, kid? Heat got -3. What about others? What we will do? First normal, without using much brain. Top to bottom minus bottom to top. So minus x square minus of x minus 1, x plus 1. Correct. So minus x square, this is what? A plus b, a minus b. So minus of x square minus 1. Correct. That is equal to 7. So minus x square plus 1 equal to 7. So what we got? Minus 2x square is equal to, send it that side, 6. So x square is equal to -3. Can it be possible? No solution. Can it be possible? No solution. Clear? Not defined. How did you give answer? 1, 7, correct. Heat -3. I asked what's the value of x, not x square. So let's say if somebody said x, you gave the answer, not defined. What if somebody is asking x square? In that case, the answer will be defined. In that case, answer will be defined. Option, if whatever the option is -3, you tick it up. Clear? That time don't say, sir said yes, x square is equal to negative. So not defined means, see what is the question they're asking. Okay. If square of any quantity is negative, that is not defined. But just normal square is there, that is negative. That value is there for them. Okay. Clear? So here if they're asking for x square, it will have value -3. But for x, we can't do. X again, if they have given the answer in the complex form, yes, we can go for that. Okay. You copied wrong question. Very big mistake. Never do commit such mistakes. Correct. Wrong question copying, no, it can make same heat cheating. Both copying each other. What, Bluetooth connection or Wi-Fi connection? Two people in two different areas copying with the Wi-Fi connection. One doing the same mistake as other. Okay, let's see the next one. Good. Now understood everybody? Anybody has any doubt on this? Anybody has any doubt on this? You can say it. Any doubt, do tell it, no issues. Okay. Okay, next. Let's see. What about 3 cross 3? We all know how to expand and do it, correct? I'll just explain it like simple so that if somebody doesn't know also, he'll know. Okay. So what I'll do, I can expand along any row, any column. I can expand along any row, any column. Clear? 1 second just. So, one second just. Now let's see what we have here. One good question, let me pick. Okay. Now what I can do, I can expand along any row, any column. So what I'll do, let's expand along which one? Column 1 we can do, or we can expand along row 1 also. So if I'm expanding along row 1, this one. So I'll take the first element. So when I'm taking the first element, leave that row, leave that column. Leave that row, leave that column. Okay. So we'll see one small determinant part will get, that will be there. So first element into whatever the column I've left, that row, that column, done. So what I got, A11 into this part, correct? Now one thing matters here, the sign part. A lot of times people mug it up, but no need to mug it up. It's very simple, minus 1 power I plus j. Minus 1 power I plus j. For the first term, since the summation of I plus j, if we add I plus j, we get a even number. So minus 1 power even is positive. For the second part, it will be what? Negative. For the third, it will be again positive. So like that we can do easily. Okay. So here what we are having is minus 1 power I plus j, A11, and then leave that row, leave that column. You will generate one more determinant, that part, plus go for the second element, A12, minus 1 power 1 plus 2. Again leave that row, leave that column. You will get this and this element as a determinant part. And then the third one, minus 1 power 1 plus 3, I plus j, A13, and then leave that row, leave that column. So this time you will generate these two. Okay, done. And then solve it. Clear? You can better understand with a simple example. Let me show with a simple example if you're able to calculate or not. Everybody knows, I'll just give a simple example question so that you don't do a mistake, okay? And this time don't copy the question wrong. A small disclaimer to all, don't copy it wrong, kids. Let me see who will get the determinant correct. Very simple question. Once or twice we have seen in CT also, very simple, directly they'll put up. Very simple question, who will get it correct in the fast form. Let's see, I'm checking for all kids who is the fastest. Come on, come on, come on, answers, answers, people. Minus 4. Karthik, you can't take your answer back this time, huh? What about others? Anyone to challenge Karthik? What about others? Come on, come on, come on. Oh, Lucky supporting. Minus 4, minus 4. Keshav also minus 4. Heat minus 4. Everybody going with minus 4 only. Is it correct? What do you say? This 1 and 2. Leave this. What are you getting? 4 minus 1, 3. Minus 2 into leave this with 6 minus 1, 5. And plus 3 into if you leave this, 3 minus 2, so 1. Oh, so we got 6 minus 10, that's minus 4. Pretty good, pretty good. So Karthik, good. This time no copying wrong. Well done. Now, next. Now what happens, sometimes we see we have options where, what do you say, there are number of more zeros. So what we do, we can expand along those rows or those columns where more zeros are there, it makes our life easy. Okay, in exam it makes it difficult if 0 comes out in the paper, or parents will give good danda. But in determinant, if you find a row or a column with zeros, you can expand along that. Make simple. Clear? Done. Now next, this is also simple part. Done. Here simple. Also no issues. Okay. So everybody knows all this part also. Now, coming to the properties. Okay. So again, till here, everybody, any doubt in the determinant part? Any doubt, anybody? Now for those who want to have food, they can bring the food here, okay, and start, and along with watching it, doing it, they can do it, okay. Target is get the hungriness of, what is it, scoring a marks or a rank less than 1000, okay, that should be there. Now, properties of determinant. What are the properties? Det of A and det of transpose of A. If you do the determinant of a simple square matrix, or you transpose and do it, same thing, no issues, okay. Clear? Done. Coming to the next property. Just discussing the property might sometimes it helps a lot, okay. So you should know it, okay. Clear, everyone? Now, if I change any two rows or column, what happens? Sign of the determinant changes. Any two row, if I interchange, row 1 I interchange with row 3. Means top, whatever the people were there, I put it in the bottom, and bottom people on the top. So what will happen? A minus sign. What will happen? A minus sign. Nothing more than that. Clear, everyone? Now what if I do two changes? One change brought a minus. The other change will bring one more minus. So minus into minus, we all know plus. So if I'm doing 2 times change, well and good for me. Clear, everyone? Any doubt till here? Clear, everyone? Any doubt till here? Okay. Next. If any two rows or columns are identical, means same. If they are same or in same ratio, means one is double the other, triple the other, 4 times the other, or like half times the other, okay, then directly you can put 0. Directly you can put 0. Clear, huh? How do? We subtract it, nothing more than that. If two are same, let's say 1, 1, 1 and 2, 2, 2. So what you can do, take the first, what do you say, this row, second row is equal to second row minus 2 times of row 1. Multiply this whole thing with 2, subtract it, you will get what? The second row is 0, 0, 0. And we all know in determinant, if all the rows, any one row full, all elements are 0, or all in a column, all elements are 0, means 0 only. Determinant value will be 0 only, because we will be expanding along that and we'll get 0 only, correct? Clear, huh? Or anything went above head? Did it went bouncer or okay? Come on. Bouncer or okay? Okay, no response. A bit faster you do type on the chat section so that we can go a bit more faster. Clear, huh? Okay. No response as of now. Anyone? Full toss. Oh, kid, you should have told me. See here. What I'm telling is, but full toss can be good thing also, bad thing also. If you're able to play a full toss, it can go for 6. If you're not able to play a full toss, missed, wicket gone. So Karthik, it's has a double meaning. Which one you want me to take? It's difficult. It's a good full toss or a bad one? Let me explain only. Once again, I'm explaining, okay? See here, everybody understand? Okay, means understood, okay? The full toss means a lot of things, okay? Sometimes for people who are on the cricket part, Like since we used to play a lot of cricket, so for us, if a good full toss, the person missed, means gone. Good full toss, the person took the chance, again gone. Okay. Okay, chats are getting late. Okay. Today something or the other is happening, but okay. Okay, now I got it. So chats are coming a bit late on time. Okay. Next. Let's see the next part. What we have here is, next part is, if each element of a row or column is multiplied by determinant of a determinant is multiplied by k, then this one will be k times the old. See, earlier it was different, here it is different. Earlier and here a bit difference is there. If you just multiply k to the determinant, means any one of the row will be getting. And for a matrix, if you are multiplying, each and every row, each and every element were getting multiplied by k. Each and every element was getting multiplied by k. Here is the difference, students. Here is the difference. Clear? So we should understand this very important and be very careful on this. Clear? So whenever we say that we are multiplying any row or a column by k, so it means that row and that column is only multiplied by k. Clear? Got it, everyone? Okay. Next property, very simple, very easy. If we can, any rows or column, we can write in split and write. Okay. Let's say this first row, two elements, we are able to split. So we can make two determinants where we have taken the first one as the first elements and the second one as second elements. Now people will say, sir, can you take one part of this, one part of the other? Yes, you can definitely take. Okay, because 2 plus 3 and 3 plus 2 is the same thing. If somebody wants to write in some other way, like A1 and then here lambda 2, here lambda 3 also, you can write. No issues in that. Clear? Okay. Now, and it is not only for the first row, it can be for any of the rows or any of the columns. If they are written as a sum of two elements, we can easily, split it up. We can easily split it up. Clear? Now, and the value of the determinant even after splitting remains the same. Value of the determinant even after splitting remains the same. It's basically like you're writing 5 is equal to 2 plus 3. Even if you split and write 5 is equal to 2 plus 3, will 2 and 3 writing separately and adding it up can give me a different value? Illa. It won't give me a different value, correct? It will give me the same value 5 only. So we should understand that. Clear? Now, so this is all that much of bullshit drama we don't need. Simple explanation, get it done. We have to just keep in mind, apply it. Very important market, very important market. One question chances are always there. One question of getting it from here, the chance is always and always there. Okay. Now, I haven't got any single chat till now. Maybe it is loading late or you're not typing. All okay till here? Seventh property, very important. Okay. Whenever, see what we are doing first, to the matrix A, square matrix A, we are multiplying with k. So if it is of like 3 order, so how many times you are multiplying? 3 times. So that's why k power the order. K power the order. Clearer? Like we can understand with this. Let's say we have a matrix A is equal to 3 cross 3. Clear? So in this, it is multiplied with the first row, second row and the third row. So if I am doing k times of A and then determinant, that is equal to k power, means for the first one power, for the second one and for the third. So 3 times it is coming. So k power 3 into determinant of A. So very important, where 3 is nothing but the order of matrix A. Order of matrix A. Clear, everyone? Any doubt here? I've just showed, I've taken a matrix A, multiplied with k. all three rows got multiplied with k. Then determinant of k of a, what I can do? Take k from the first row, k from the second, k from the third. So I'll get 3 times k and then the determinant. So k power 3 into determinant of a. K power 3 into determinant of a. Anybody has any doubt in this? Anybody, any doubt? Yes, no, yes, no. Okay. Got it, got it. Again, same request to you all. Do inform all your friends about the crash course. Whoever wants to do, whoever doesn't want to do also. And tell them we are having some live sessions also, and rest is for the crash course part. Okay. Tomorrow morning we are having again class. Okay. Sharp 10. In the app sharp 10. Okay. Now, next property. Very important, 8th property. A lot of people, they don't know. Like, let's say I have a diagonal matrix. Okay. A11, A22, A33. Rest all is what? Correct? 0. So in this case, what is the determinant? In this case, what is the determinant? Multiply the diagonal. Multiply the diagonal. A11, A22, A33. Multiply the diagonal. Multiply the diagonal. Nothing more. Clear? Everybody clear, clear? I've put up the example here. You can see determinant of 1, 0, 0, 0, 5, 0 and 0, 0, 7. So what are you getting the answer? 1 into 5 into 7. Just the diagonal elements you multiplied. So 35 answer. Clear? Anybody? Any doubt? Okay. Now next, A and B are square matrix of same order. So determinant of AB is nothing but determinant of A into determinant of B. You can open split up also and you can do. No issues. Power is there and then determinant. So you just do the determinant first, then do the power. Same thing. No issues. If by putting x equal to alpha, the value of determinant becomes 0, it vanishes. Just like polynomial, we'll say x minus alpha is a factor. Okay. Clear? Just like same thing in a polynomial. We have a quadratic equation fx is equal to ax square plus bx plus c. Now f of 3 is equal to 0. It means what? 3 is a factor. Or what is it? 3 is a 0 of this polynomial and x minus 3 is a factor. Clear? Same thing here. Nothing change. Clear everyone? Anybody, any doubt? Clear everybody? Okay, okay. Now, next. Understand this point. Very important. Okay. Determinant of A is 0. Okay. So it means what? Singular matrix, inverse not possible. Because we know 1 by 0 not defined. 1 by 0 not defined. Correct. And if determinant of any matrix is not 0, means non-singular, then inverse possible. So we got the condition. What is the condition for the inverse? If the determinant of A value is not equal to 0, then only inverse exists. If det of A is not equal to 0, then only we say inverse exists. Clear everyone? Okay. 1 second, I dropped the pen. Everybody got it? Okay. Next. Now, let's see the next part. Now, if I am doing the determinant of a skew-symmetric, determinant of a skew-symmetric matrix, it depends on what? It is 0 if it odd, if the order is odd. Simple. If I have a skew-symmetric matrix and the order is odd, means order is 3, 5, okay, so directly I'll put 0. If it is an even order, then it will give me a perfect square. Very, very, very important. If it is a even order, it will give me a perfect square. Okay. Take a skew symmetric. Let's say I have taken A, and A is a skew symmetric. So if the power of A, order of A is like 2 cross 2, then it will give me a perfect square. And if the order of A is what, 3 cross 3, it will give me a value 0 directly. Clear? If I know A transpose is equal to minus A, means skew symmetric, and then if I am doing the determinant of A, and I know the order is odd, means the value is 3 like this. So directly I can say det of A is equal to 0. And if I know the order is even, so it will give me a perfect square. It will give me a perfect square. Clear, everyone? Any doubt, anybody? No doubts. Okay. So if I do inverse of a determinant, it will nothing but just reciprocate. Nothing but just reciprocate. Simple. Clear? Again, I told you earlier also, if AB is equal to 0, then determinant of A and determinant of B is equal to 0. This and the earlier property, bit slight difference is there. In the matrix part, it can have, in here, it has to be 0. Clear, everybody? Yes, no? It's almost, we are going to hit the next day. Any difficulty? Next, some places like real life application of determinant. We want to find the area of triangle. We know the vertices. The vertices is given to be. Area of triangle is equal to what? Half into, put the first vertex x1, y1, second vertex x2, y2, third vertex x3, y3, and then 1, 1, 1, done. Then solve the determinant. Clear? Can you repeat the 12th property? 12th. Okay. Here, what we have to do, take a skew-symmetric matrix. Let's say what I'm doing is, I'll take like this. I've taken A, which is a skew-symmetric matrix. Okay. Now I can predict what will be det of A by knowing what? If I know the order of A, if I know the order of matrix A. If it is even order, then the det value will give me a perfect square. It will give me a perfect square. And if it is of odd order, like n equal to 3, here put n equal to 2, odd order, then that value will be equal to 0. This only two things it says. If I have a skew-symmetric matrix and I know the order, if the order is even number, it will give me a perfect square. If the order is an odd number, the value will be equal to 0. Got it, Heat? Come on. Got it? Didn't get? Got it? Didn't get? समझ आ गया आपको? हिट सर. Okay, chat section, maybe it is coming slow. Understood. Okay, good. Let's erase it. Next, area of triangle, we all know how to do it. Now, area of triangle is always a positive quantity. So when they say area equal to 4, it means we have to use both 4 and minus 4. for solving the calculation, because if we get area equal to -4 also, since area is positive, so we'll write it as 4 only. So that's why whenever you get area value, put these 4, positive and negative and both, and then do it. Clear? Otherwise you'll be skipping some answers. Some of the solutions will be skipped. So never do that. Clear? So never do that. Clear? Now, let's give you an example of question. Okay. Try this question, everybody. Let's see how many of people can attempt this question and solve it properly. Let's see. Come on, come on, come on, fast. Excuse me. What will be the answer? K equal to 1. We got lucky, Sony. K equal to 1. Let's see. What about others? Karthike +2. Okay. What about the others? Still. What about others? Heath. Lucky, changing again. Options you won't get an exam, kid. Once you have marked 2 wrongly and you are a person, let's say you are doing in marking, means gone case. Okay. So before saying be sure and then say. Before marking an exam, be sure and then mark. Okay. Now Karthike, changing again. It is +-2, sir. Just now I told, whenever you have area, take both positive and negative. Whenever we have area, take both positive and negative. So for those who have done just with +3, they'll get 1 answer. For those who have done with +-3, they'll get this answer. So a lot of people will do mistake here. Very simple question, but again, I can make you do mistakes here. So again, be very careful. Okay. Small things, and later you'll be like, sir, I knew everything, sir. I did everything correct. The Kcet people, they cut it, sir. Comedk people. Okay. Nothing like that. Okay. Now, collinear means 3 points lying on a line. Area is laddu. 3 points lying on a line. Area is 0. Nothing else. Okay. Next. Minors, cofactors and adjoint. Till here, anybody, any doubt? You're all able to continue or having difficulty? Honest answer. Not changed, sir. Oh, you wrote like +-2. Correct. Okay. Got it. Minus was not that visible, so it's okay. Then it's good, Karthik. You all are able to continue. Yes, no in the chat section. Energy is there or is it depleted? Because we have what? Minor, cofactor, adjoint, and then the properties. Inverse. Done. Done. This rest is same. That's it. So 4 to 5 more pages are there. You have the energy to finish it, everybody. Number of viewers after, what is it, 10, 11, 30, it's like almost they're done. Okay, rest others, you have the energy, whoever is there. Yes, no, put it in the chat section. We'll start. Oh, Karthik, tomorrow because your exam is there. 15th, what you have? Which exam tomorrow? Which exam is there? Oh, that Manipal exam. Okay, you all have to catch early train. So then students, for today, drained. Okay, so for today we'll keep it till here. Okay, tomorrow morning we'll have the class. Okay, for today we'll keep it till here. Keep it till here. We'll see you in the next class. Till then, work hard, be happy, be dedicated. Okay, Jai Hind, students. And best of luck for the Manipal exam. Those who are having the Manipal exam, best of luck. Work hard. Okay. Yeah, the schedule I'll send it, Piyush. Okay. What about others? Work hard. Be good. Okay. Thank you, everyone. I'll send it the schedule part. Tomorrow 10, be ready. Okay. Done.